All right, Mr. Ahmed here for 3.7. Goal for today is to graph absolute value functions. So these are going to be a little bit different. How do I graph an absolute value function? So we kind of skipped over absolute value a little bit in inequalities. So the last time we saw it was when we solved absolute value equations. So just like we talked about then, the absolute value is indicated by two bars. For us to graph it, we are going to find a target point, and that is the value that makes the absolute value equal to 0. So whatever is inside the absolute value has to be equal to 0. That's our target point. We are then going to make a table of the values. The target point's in the middle. We're going to plot all these ordered pairs and then draw the V-shaped graph. So the graph looks like a V. Could go up, could go down. We'll then describe the domain and the range. So absolute value equation graphs look like this. We could have a V going up, or we could have a V going down. Okay, those are the two ways that we're going to see them. So the first thing we're going to do is just practice finding the target point. And the target point is when the absolute value is equal to 0. So what's inside the absolute value for the first one? X minus 9. So you could probably do that one in your head. What value makes that 0? X would have to be 9, but I'm going to write it out. X minus 9 has to equal 0. Add 9 to both sides. And x has to equal 9. So our target point would be 9. That's where we're going to start. The next one, what's inside the absolute value? In this case, it is x plus 6. So the value of x that makes that equal to 0, I'm not going to write this one, is negative 6. Because negative 6 plus 6 is 0. Now, when there's a fraction or something, these ones are a little bit tougher to solve. So this one, we are going to write out the equation. And we have to figure out the target point. So when is 1/2 x minus 6 equal to 0? Add our 6. And we get 1/2 x equals 6. And then multiply both sides by 2 times by 2. X is equal to 12. So that kind of makes sense. Half of 12 is 6. 6 minus 6 is 0. So we are going to have to find these target points. Now we're actually going to draw the graph. So with our XY chart, X is on the left, Y is on the right. Our first step is to find the target point. So this one's pretty straightforward. The absolute value is just simply X. So the target point, TP, is equal to 0. So my graph is going to start at 0. I put that in the middle because I need to pick some numbers bigger and some numbers smaller. So the smaller ones, smaller than 0, are -1, -2, -3, and bigger is 1, 2, and 3. So we have to figure out what y is, or what the function is, when x is 0. So when I plug 0 in, the absolute value of 0 is 0. Plugging in for x. -1. The absolute value of -1 is 1. Absolute value of -2 is 2, and the absolute value of -3 is 3. In a similar manner, absolute value of 1 is 1, 2, and 3. So when I draw my graph, plotting these points, my first point, 0, 0. I have 1, 1, 2, 2, and 3, 3. And going to the left, -1, 1, -2, 2, -3, 3. And our graph is a nice V. And it keeps on going. So, the domain, all the values of x values. It goes left forever. It goes right forever. All real numbers. The range, it goes up forever, but it does not go down forever. So the smallest value of y is 0. So y is greater than or equal to 0 for the range. All right, next one. Find the target point. So the target point, T dot P, what makes this equal to 0? Well, I can do this one again in my head. Negative 3, because negative 3 plus 3 is 0. So I'm going to start at negative 3. Numbers smaller than negative 3 are negative 4, negative 5, negative 6, xy. Bigger, negative 2, negative 1, and 0. So when I plug these values in, negative 3 plus 3 is 0, so y is 0. Negative 4 plus 3, we're plugging it in. Negative 4 goes in for x. Negative 4 plus 3 is negative 1. Absolute value of negative 1 is 1. Negative 5 plus 3 is negative 2. Absolute value is 2. And then this one is going to be 3 because it's going up by 1. So negative 6 plus 3 is negative 3. Absolute value is 3. Now go in the other direction. When I put in negative 2, negative 2 plus 3 is 1. Absolute value of 1 is 1. Negative 1 plus 3 is 2. Absolute value is 2. And 0 plus 3 is 3, so we get 3. So those are my points. So this graph shifted to the left. Our first point is negative 3, 0. Then we had negative 5, 2. Negative 4, 1. And the other side follows the same exact path. It's going up 1 over 1. And we draw an RV. We got it. All right, next problem. This one's a little bit different. What makes the absolute value equal to 0? The target point is 0. So we have 0. Smaller numbers, negative 1, negative 2, negative 3, x, y. 1, 2, and 3 are the bigger ones. So we have to pick some smaller than the target point and some bigger than the target point. Now when I plug these in, absolute value of 0 is 0. Make sure you take the absolute value first. I follow the order of operations. 0 minus 2 is negative 2. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. Absolute value of negative 2 is 2. 2 minus 2 is 0. And the absolute value of negative 3 is 3. 3 minus 2 gets us 1. Going the other way, 1 minus 2 is negative 1. Absolute value of 2 is 2. 2 minus 2 is 0. And 3 minus 2 gets us 1. Kind of sped up there. Notice they follow the same pattern from the target point. Okay, same pattern from the target point. So when I plot my target point, I'm at 0, negative 2. So left, right, 0, down 2. Negative 1, negative 1, 1, 1, negative 1. At negative 2, we're at 0. And we're also at the point 2, 0. So right 2, up 0. And there is our nice gentle V. It keeps on going. Absolute value has been graphed. I forgot to do the domain and range on number 2. So I'll do this one first and I'll go back. So the domain. Left forever, right forever, all real numbers. The range, this one goes up forever, but not down forever. The smallest value of y is negative 2. So y is greater than or equal to negative 2. I skipped this one on accident. Here we are. Left forever, right forever for number 2. The domain is all real numbers. And the range goes up forever, but not down. Y is greater than or equal to the smallest value of y is 0. All right. 2 to go. First step, find the target point. Target point here, x has to be 4. 4 minus 4 is 0. So we're starting at 4. Numbers smaller are 3 and 2. And 1, numbers biggers, 5, 6, and 7. So I went 3 lower, 3 bigger. Target point here. X, Y. Now we have to plug them in. 4 minus 4 is 0. 0 times 3 is 0. 3 minus 4, or sorry, yep, 3 minus 4 is negative 1. Absolute value of negative 1 is 1. Then you multiply 1 times 3 to get 3. When I put in 2, 2 minus 4 is negative 2. Absolute value of negative 2 is 2 times 3 gets us 6. So it's going up by 3. This would be 9. All right, when we put in 5, it should follow the same exact pattern. We should get a 3 here. Let's see if we do. 5 minus 4 is 1. 1 times 3 is 3. 6 minus 4 is 2. 2 times 3 is 6. And we should get 9. So on our graph, right 4, up 0. Right 5, up 3. 1, 2, 3. So this one's a little bit steeper. And then we could connect our points. And our graph is complete. I will now do the domain and range. Domain, this graph goes left forever. It's pointing that way. It's pointing to the right, so it keeps going right forever. So all real numbers for the domain. And the range, it goes up forever, but not down forever. Y is greater than or equal to 0. Smallest value of y is 0. All right, last one. I would recommend giving this one a pause and you try it out, then restart. All right, hopefully you did well. So, target point first, TP. What value makes it 0? X has to be 3. 3 minus 3 is 0, starting at 3. 2, 1, 0, 3 numbers smaller, bigger, 4, 5, and 6. Target point first. 3 minus 3 is 0. So this one's going to take a little bit of work. 3 minus 3 is 0. Then I have to multiply 2 times 0. So when I plug this in, you got to be a little bit careful here. You're going to have to add and subtract last. So when I put in 3 minus 3, I'm going to actually write this down. When you do it, you will have to follow this process the whole time. 3 minus 3 is 0, so 2 times 0, or the absolute value of 0, plus 4. Absolute value, 2 times 0 is 0, plus 4, we get 4. Now when I put in 2, this will change. 2 minus 3. All right, I'm going to put in the 2. So 2 times 2 minus 3 plus 4. 2 minus 3 is negative 1. Have to take 2 times the absolute value of negative 1, which is 2 times 1 plus 4. That is 6. All right. Now when I put in 1, I'll do this one in my head. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. Plus 4, I get 8. Then I should get 10, 6, 8, 10. It follows the same pattern. So plot the target point first. Over 3, up 4. Then from there, I had the point 2, 6. Then I had the point 1, 8. And 0, 10. And this one follows the same exact pattern. There is our graph. It is complete. So, the domain, it goes left forever, it goes right forever. Domain, all real numbers. And the range goes up forever, but not down. Y is greater than or equal to the smallest value of y this time. 1, 2, 3, 4. Y is greater than or equal to 4. All righty, have a good rest of the day. That wraps up chapter 3.